Good morning. My name is Jenny Whittle and I'm a professor of Geomatics.
And I'm Dr. Simon Hull, the current program convener for Geomatics.
Welcome to the Geomatics 2021 Virtual Open Day. We're glad that you're interested in learning more about geomatics and hope this presentation will help you to understand the program and the opportunities for graduates in the work environment.
At the end of the presentation, we'll be answering your questions. Please write these into the question and answer tool. But for now, sit back and relax while we introduce you to the world of geomatics. Spatial positioning is core to the discipline of geomatics. This involves describing the relationship of data in space and time within a multidimensional coordinate system. This ability may be devoted to the measurement of the Earth, the mapping of nations and the seas, the control of engineering projects, and the recording of property rights in professional land surveying. Geomatics is both an applied science and a professional discipline. As an applied science, a student of geomatics is involved in spatial science, that is, the collection, analysis, management, modeling, and communication of spatial data. As a professional discipline, the degree is endorsed by the South African Geomatics Council for various registration categories in a profession that engages in a wide range of disciplines, including engineering, environmental sciences, land administration, and law. The profession has undergone some changes over the years. I studied an undergrad in surveying and mapping in the 90s. Around that time, there was an international move to rebrand it as Geomatics to recognize the integrated, cross-disciplinary influences that have been shaping the profession, such as satellite positioning technologies, for example GPS, and information systems infrastructures such as GIS. UCT adopted this name in the early 2000s. We are now talking about rebranding again to recognize modern influences and opportunities. Whatever we call it, our history dates back to the Egyptians and Babylonians, but that doesn't mean it's outdated. You'll learn a wide range of skills and knowledge using state-of-the-art instruments and software to address many modern challenges, such as big data management and the fourth industrial revolution, spatial data science, land reform, spatial inequality, climate change, and many more. That means you get hands-on experience to measure stuff with equipment ranging from ordinary tape measures to laser scanners, drones, and satellites. You will learn how to operate equipment to get the best possible measurements. You will also learn that no measurement is error-free and how to handle this reality. You will learn skills related to understanding errors and how to handle the effects of measurement errors to get the best solution, so that when you say that Table Mountain is 1,086 meters high, people believe you because you're the best qualified person to make that statement. You will also learn how to manage your data. We collect a lot of data, so big data management is important. You will learn how to use your data to create models of the physical and natural world. By models, I mean two things. Firstly, simplifications of reality in the form of 2D maps or 3D virtual models. And secondly, forecasts of what could happen next. For example, what would happen if the sea level rose by 1 meter? How fast is vegetation in a certain area diminishing? You also learn how to make sense of the data to answer relevant questions, such as where is the best location for a wind farm? And we teach you how to communicate your findings, predominantly using maps, but also with graphs, charts, tables, and reports.
Within geomatics, there are some specializations. The first image shows some of the work environments in the surveying, land surveying, and geodesy fields. Here you could be measuring land for property development purposes or surveying other objects such as ships, factories, or even film sets. Geodesy is the specialization in which you'd be helping in the measurement of sea level rise and continental drift, millimeters over large distances. Or you could be involved in monitoring and controlling global satellite systems such as GPS. A professional land surveyor spends about half their day in the office and the rest conducting field work. They measure property boundaries to create new land parcels. This image shows a general plan of a piece of high-value coastal land in Milnerton outside Cape Town. This type of plan is a legal document and shows the spatial location and extent of land ownership. It's linked to the title deed, which has the verbal detail of the property rights. This is the shape of the equipotential surface of the Earth. It's a surface of constant gravity we call the geoid. It approximates the shape of mean sea level if there were no continents. A geodesist models this surface from actual measurements of gravity made on the surface of the terrain, and also from satellite measurements of gravity. Geodesists also measure the movement of the Earth's rotation axis and its continents. This map shows the vectors of current plate tectonics measured using satellite positioning techniques to millimeter precision over large distances. Sea level rise can also be measured and modeled. It's not an easy task as the changes are small, also over very large areas and long time periods. And when one considers the Earth, everything is moving. Tidal forces of the moon and the sun not only pull the water, causing sea tidal variations, but they also cause the land to rise and fall by about ½ meter with each cycle, called earth tides. Ocean loading is the weight of the high tide on the Earth's crust, causing it to deform. All these effects need to be modeled in the determination of sea level rise. Once predictions of sea level rise are made, these can be used in a GIS simulation of the potential flooding of coastal areas, such as we see in this image. Some surveyors choose to move into the hydrographic surveying field of work and spend time offshore. They would typically be involved in mapping the seabed as well as surface and subsea structures such as pipelines, fiber optic, intercontinental internet cables, and mining structures. This slide illustrates remote sensing from Earth-orbiting satellites and airborne laser scanning. Satellite images of the Earth are used along with ground-based data sources and even images obtained using fixed-wing aircraft or drones. These are all imported into a geographic information system, allowing the geomatician to manipulate and analyze the data and create maps and plans for various purposes, as shown on the right. Terrestrial laser scanning is a growing and exciting technology. It involves measuring objects using the distance a laser beam travels to an object and back again. Each distance and its direction is used to create a point coordinate where the laser beam was reflected off the object. Many points are created and are called a point cloud. This object, the Peace Memorial Museum in Zanzibar, was scanned. This is the resulting digital model created from the laser scanned data. And here is a bird's eye view of the point cloud. From this data, a surface can be created over the points, and in the end, the digital model looks like the real object, and measurements can be made from it in 3 dimensions. It's a technology that is becoming widely used in the gaming and film industries as well. We have a number of internal laboratories, and even some outdoor ones. Many of our students love the outdoors and enjoy the fieldwork, while others prefer to be indoors. We run both laboratory-based camps and fieldwork camps. These camps are a great way to consolidate knowledge and to bond with other students and talk informally to staff. In Geomatics, we have only about 40 students in each first-year class, so we're more like a family. Strong relationships are forged, which can last a lifetime. Geomatics offers a 4-year professionally accredited BSc Geomatics degree with 2 streaming options, surveying or geoinformatics. Surveying students take all geomatics courses, while geoinformatics students take some geomatics courses and then choose another major from the science faculty. The options are environmental and geographical science or computer science. As a student of geomatics, you would take courses in mathematics, physics, environmental science, computer science, and statistics to provide a platform for geomatics courses later in the degree. A UCT degree in geomatics is recognized worldwide and offers exciting opportunities in a rich and varied lifestyle, working in or out of doors. Graduates are equipped with a highly marketable toolbox of both hard and soft skills, the degree that reflects the diversity and interdisciplinary nature of the practice environment. There's a shortage of professionals in surveying and geoinformation science both in South Africa and abroad, resulting in good employment prospects. Career opportunities exist in consultancy practices, aerial survey companies, offshore survey companies, mining houses, and of course in government.
So what do you need to do geomatics? Well, the entrance requirements are clear. You need maths at 75% or above and physical sciences at 70% or above, because maths and physical sciences are both really integral to most of the subjects that we cover. You need a faculty point score of 450 or above. We do accept at 10% below these requirements for the maths and physical sciences and offer as much support as we can where this is needed.
We now hand over to Associate Professor Adira for the question and answer part of this session.
Welcome to the Q&A session. This is a very interesting session where we are willing to answer some of the questions that you may have concerning geomatics and the programs that are related to geomatics. So please feel welcome to post your questions on the Q&A section. It is live right now. I have not seen any questions so far, so I'll be waiting to pick them up as they come up. Just to mention that we have got Prof. Jenny in the room from Geomatics. We also have got Sumi from Geomatics. I hope they'll be joining, or they have already joined. We have Rahman from administration, and we have Ogla in the background dealing with the IT issues. So thank you very much and welcome. Maybe I can start with some of the common questions that students normally ask from the previous open days. Students will always want to know where they can work with the Geomatics program, and I can say some of the areas where Geomatics students can work or graduates, and some of them are in the IT section, some of them are in the agriculture segment, and something like geothermal exploration and exploitation, like siting of potential wind and solar power plants. So that is in the energy sector, mapping and monitoring field crops, growth, and of course production to predict yield. So that one is in the agricultural sector. Mapping of ground and surface water, including vulnerability to contamination, that is in the water sector. So we have got very many areas of applications, including modeling floods and landslides. So that one is also in the water and environment sectors. You may also think of other areas like measurement and determination of orbits. In this case, I mean satellite orbits. So basically, you can work with South African National Space Agency and of course the South African Astronomical Observatory. You may also work in the measurement and determination of the dynamics of the Earth crust. And in that case, you'll be working with the Council for Geoscience, and of course, very many other areas. So as I wait for your questions, please can you post them through, and I'll be able to respond to them, and also ask my colleagues to respond to some. Okay, maybe I can move on and talk about navigation and guidance of aircraft using satellite and inertial navigation systems. So in this case, you'll be able to work with civil aviation and of course defense, spatial mapping of human settlement, and even human diseases, including animal diseases. And so in this case, you can be working with health or Ministry of Health. We also have got topographic mapping using satellite and terrestrial or ground-based techniques to facilitate structural planning and construction. And in this case, you'd be working in the construction industry. We also have virtual reality modeling, and of course, this is applicable in e-commerce. We also have got tourism, marketing, and property management. So if you are thinking about business and tourism sectors, this course is very relevant for you. And measurement and subdivision of land is also something that most of the attendees must be aware of, a very hot issue in the country and even elsewhere. And so you may be thinking of Department of Rural Development and Land Reforms, and of course the private surveying sector. Of course, setting out of engineering structures, this whole range of field of work that geomaticians do, and they work in the construction industry too. And so can I have some questions, please, that I can respond to from the participants? Maybe I can ask Rahma to give us some indication about application. When are the applications expected this year?
Hi, our applications have already opened for the 2022 admission cycle. You can apply online at applyonline.uct.ac.za. It's also important for the applicants to use the 2022 undergraduate prospectus, which lists all of our programs on offer, as well as the requirements that are needed for the specific programs. There are the National Senior Certificate entrance requirements listed, as well as the non-NSC requirements. So if you have any international schooling, you can find the requirements in the prospectus as well. The requirements are listed on pages 31 to 33 of the prospectus.
Thank you very much. I would now want to welcome Tsumi, who is one of our final year students, to give us some of her experiences with Geomatics program. Welcome, Tsumi.
Thank you, Dr. Dera. Hello, everyone. My name is Ntsumi Makwarela, and I'm a final year student studying geomatics at the University of Cape Town, majoring in land surveying. What inspired me to study geomatics was my passion for geography. I saw the possibility in the degree in helping me find a career that was related to geography. And also would just enable me to become a change maker in society by equipping me with the relevant skills and the knowledge required or necessary in the transformation of the built environment, especially in marginalized and previously disadvantaged areas in South Africa. Although I must add that geography is not necessarily a requirement in applying for the degree. What made me choose UCT or want to study geomatics at UCT in particular was the diversity of the degree. Although I'm majoring in land surveying, I still got exposure to other fields such as geographical information systems, town planning, which I want to further specialize in, photogrammetry, and even geodesy, all of which have been well combined in the geomatics degree. My experience or my academic experience has been wonderful, and I'd say that's owing to the world-class experience at the University of Cape Town. The facility, okay, as a geomatics student, you do spend quite a lot of time in the geomatics labs, all of which have been well equipped with current software and applications, all relevant to industry. And not only that, but in addition to your theoretical learning experiences, the geomatics degree also has a camp which is hosted in the outskirts of Cape Town, where you get to further bond with your fellow classmates, explore more of the scenery even of the Western Cape, while importantly still covering the practical aspects of the degree as well. So these have all just essentially made my experience quite holistic, and I would definitely encourage anyone who wants to see themselves as a change maker in society to definitely apply. Thank you.
Thank you very much, Sumi. We have got a question now on the chat. Someone is asking, this Tandy, asking about changing from doing EGS program in 4 years instead of in 5 years instead of 4 years. Yes, it is possible, Tandy. You can choose 5 years, especially after in second year. if you are in second year, you can choose to move to our aspect program, and in that case, you can complete your program in 5 years instead of 4 years. The other question is down there, Sandy again asking about moving to sociology. Jenny, can you see that question from Sandy and respond to it? Is almost the last one.
Sorry, I've been struggling to get in. So I see. Are there many job opportunities in this field? Is that the one?
No, down there.
From Tandy.
Yes, I sent through my application for BSc Geomatics EGS stream with intention to go on to specialize in comp science. If I was to choose the 5-year course instead of 4 years, would I be able to fit in a few lectures a week at the Department of Sociology? So
yes,
I may not be able to respond for the Department of Sociology. I don't know whether you have got some ideas about this.
Yes, it all depends on the timetabling. So yes, you certainly can take options from sociology, although the comp sci stream is really very difficult and very full. So it's difficult to fit in extra courses, but it's certainly something we'd be able to advise you on right at registration, and we'd be able to have a look at what sociology courses are there and what fits in with the timetable and so on. So if you have a deep interest in the humanities, as you say, certainly we try to work around that as much as possible. But getting a major in computer science, it is a very full program with the geomatics as well. So it does become problematic. It all depends on how much you can cope with as well. If we can see that you're coping really well, then you can take on more. If you're not coping so well, then we advise you not to. So it does really depend on those factors.
Thank you so much. I think it will be very difficult to do the two, but maybe you can try. I think we are getting towards the end of our time, if I'm not wrong. We are supposed to be finishing at 1:45. So I would like to thank you all for joining us in this session, and we would love to see you register with us. And don't forget to contact Dr. Simon Hall, who is the program convener for Geomatics. I've already posted his email address on the Q&A. So please do contact us, and we'd love to hear from you even later after this session. Thank you so much. Bye-bye.